Hi-oh, one more here. Force and pressure. We all know what force is, right? You push, you pull, that's a force. But what's pressure? Well, if you've ever put your thumb over a hose, you've increased the pressure. And why did you do that? Because you changed the area at which the water was coming out of the hose. So as we had a smaller area, you got a greater pressure. We end up measuring pressure in the units of pascals. One you might be familiar with is pounds per square inch. And that's on your bicycle tire or car tire. However, in physics, we use pascals. Check out this video and see if you can figure out why the cube doesn't hurt.
Listen, Lenny, I know I was a pretty bad Secret Santa, so I wanted to make it up to you.
Wow, a photo cube with pictures of us.
And I filed down all the sharp corners. See? Your eye is completely safe.
Oh, wow, it just stings a little.
So, tell me, if I weigh approximately 750 newtons, remember we have this formula, pressure is force over area. If the sole of my shoe has an area of 0.5, an area of 0.5 meters squared, and I stand on one foot, how much pressure is exerted on the ground? Well, my initial pressure is 750 newtons. Did my weight change? No, so that's not going to change. So we have this inverse relationship. So if I stand on one foot, I've done what? I've decreased my area. In fact, I've cut it in half. Therefore, my pressure should have doubled. So that would be 1,500 newtons per meter squared, which is also called a pascal. But if I'm standing on 2 feet and I exert 5,000 pascals, let's say, of pressure, how much would I exert if I stand on 1? Well, what happened? Pressure equals force over area. My weight did not change. Therefore, we're interested in that relationship. And you can think of it like we did before with the teeter-totter. If I exert 500 here, how much if I stand on 1 foot? So I've decreased. Therefore, that has to increase, should be 10,000. What about this one? How much force would I exert on the ground while I'm standing on 1 foot if I'm exerting 900 newtons of force standing on 2 feet? Careful. Does my weight change? No, I still weigh 900 newtons. I still weigh that much. Therefore, no. How much force? 900 newtons. Doesn't matter what I do to the area, it turns out, because my weight has not changed. If we were talking about something different, pushing with 1 finger, 2 fingers, stuff like that, that might be a little different. But my weight does not change. That's determined by gravity and my mass. So why isn't the balloon bursting? Well, if we have one nail, right? Pressure equals force over area. We have one nail. The area is very, very small, which means the pressure is very, very large. Here we have lots of nails, so we have a much bigger area. Each nail adds a little bit more area. Therefore, the balloon doesn't pop. You ever see something like this? Hammered by his own brother, he beats death by the strength of willpower alone. Not that impressive, to be honest with you. Take a look at this. This could be me down here. Oh, wait. I did do something like that. Another good example. So let's try it. Let's show.
Ready?
Oh man! I wanted to show you first that the bed of nails is actually quite safe, assuming you'll put a single, hand on a single nail, which we've experienced before in the past. Just lay down and I'm here. I'll maybe just got my butt even. It's perfectly safe. In fact, it feels like I'm laying on a board without no nails at all. The bricks don't hit me in the face when the brick breaks.
Yep.
Is it ready?
Yep, ready.
Is it ready for the hit? Should you put the helmet on?
Got some time.
There.
That sounded okay?
You got it? Alright, and this is a real... Oh yeah. This is a cinder block. Got it?
Helmets with some
Yeah, you want to try and keep it?
Absolutely, he is. Alright.
Just making sure. Ready?
Alright, on 3. Ready? 1, 2, 3. Oh my God, is he okay?
Check
Alright,
him
let's
for a
see.
pulse. That's your spouse, though. Yeah,
I'll do the water test so you can see that it's
Well, it's...
the other way.
Boy, it takes a little hotter and
No leaking.
Oh, a little leakage. No,
No leaking. There you go.